This lesson is part of Module 2 of the SaferAfrica Road Safety course. The module is focused on data, data collection, data management, data analysis and the relation between data and road safety policy making. The module is based on information from different courses and put together for the EU Safer Africa project. The course will be presented by Martin Narvabi-Niaki and Henk Stipdonk. You will hear our voices mostly, so in case you wonder who you are listening to, we'll introduce ourselves briefly.
On the first day, we discussed why and what type of data are relevant for road safety policymaking. The formal definitions were presented, as well as the relationship between risk, distance traveled, and the number of casualties. Today we will focus on crash data and their relevant variables, the shortcomings of crash data, and how to handle poor data quality, as well as the possible options to enhance data quality. This is the outline of today's lecture. In the first part, we will zoom in on different sources of crash data, from police reports, death statistics, hospital records, ambulance data, insurance company claims, and in-depth research. In the second part, we will list the relevant variables regarding roads, vehicles, human behavior, and external factors such as weather. The third part is dedicated to data flaws and imperfections. Incorrect data, missing variables, missing records, and how the completeness and correctness depends on the type of crash, how these can be recognized, and possible solutions. Finally, we will present the possible approaches when different crash data sources are available. In the introduction, I will talk about what to expect from police data and other crash data sources. The police don't go to a crash location to support scientific research or policy making. They are busy enforcing the law, and once they know who was legally at fault, their job is done. If a country has arranged a road crash registration by the police, they usually take care of that when it is a small effort, but they do not go into great lengths to discover something that is not relevant for their own purposes. The police force in the Netherlands has approximately 50,000 officers, each of which have to report a crash once or twice a year on average, and so there is no build-up routine. To optimize the reporting system, we can use automated systems that automatically record the basic information such as date, time, location, and the name of the officer. We can improve the reporting rate of crashes with road deaths and hospitalized by focusing on the most relevant variables only. We should make it easy to report crashes that are not relevant to the police, such as single vehicle crashes or crashes where the driver at fault has died. You should always consider and keep an eye out for what might be wrong with police data. Do not trust that formal procedures are always followed. Here we see examples of problems with police reports. Police officers may misplace their road death reports, and the police is not always present at crashes that turn out to be fatal, and if they are present, officers do not always report injury crashes. Since the police is less interested in reporting crashes with only injuries, they do not report the majority of the crashes. And because the police does not know the outcome, they can get it wrong as easily as they can get it right. Looking at other sources of data, death certificates are most important to verify the number of road deaths. This is only the case if the data is systematically gathered and made available for researchers. You would need a trusted organization that is allowed to check these privacy-sensitive issues and to compare them with police crash records. Hospital data can be used for information about patients that were treated. For deaths, this can be very relevant since the victim may die in the hospital without the police finding out, and this certainly happens in the Netherlands. Insurance companies aren't as valuable for this case. Many vehicles are not insured for single vehicle crashes, and there are many companies to check, and double records need to be removed. For this exercise, consider what source of road death data might be available in your country. You can list the possibilities and rank them according to the expected report rate and the expected usefulness for policymaking.
This section consists of some examples. I will show you the things I would do to get a better picture of road crash facts based on the data. What I usually do is try to analyze the data by making illustrative graphs of stratified numbers of crash victims. In this section I will show you road death data from the Netherlands and some from Cameroon. In our everyday practice, you should always ask yourself, what do I want to know? What can I actually do once I know the answer? When you don't know what to do with the answer, there's no need to analyze the data. Data have to be analyzed serving a certain purpose. Without a purpose, data analysis may turn out to be pointless. I would like to discourage producing just standard annual road safety reports with no other purpose than producing standard annual road safety reports. When your reports are read, they should enable answering the important question, what can be done to improve road safety? And some answers to that question are on the slide. Stratification is a way to help you select the relevant parts of the data. Stratification is the opposite of aggregation. It means we divide the data into different distinct subgroups. This is important because your safety policy will always be focused on subgroups, and there are many subgroups. Stratification is possible only when crash records allow for it, and variables, travel mode for example, are indeed always or nearly always included. In the next slide I will show you some examples of Dutch data stratified by age, travel mode, gender, time and so on, and show you what differences appear between the groups. The slides are meant to show why stratification is important. These slides are just examples, mainly useful for the Netherlands. It is important that you ask yourself which data should be collected in your country to allow you for the most proper stratifications. This graph is actually a set of about 30 time series graphs of conflict types between 1976 and 2012. We see the travel mode of the victim on this side and the travel mode of the other party on this side of the graph. Horizontal rows of graphs show victims killed in crashes with all other modes. So these are all conflict types where a pedestrian is killed by any of those on the top row. Columns show the number of people killed in a crash with the travel mode shown on the top graph. So for example, here we see people killed in a crash with a van as the other party, whereas the people who are killed were traveling on a moped, a slow moped actually, which is a typically Dutch travel mode, a slow moped. You don't need a helmet for that. On the far right we see the sum of all crashes on every horizontal row. Colors in the graph denote the number of people killed in a crash of that type. So when the color is light, there are not so many people killed in that graph. When the color is dark, there are many people killed in that graph. In this graph we can see many different trends. For example, this decreasing trend, but there are also trends like this where numbers are going up and down. We have trends like these where the number are going up. Then there are trends which are mixture of both. You will get a moment to think about what could be the causes of those differences. If you want to think about it some more, you'll have to pause the video. Here we see some more of the same graphs, but then with people killed as a passenger car occupant over here, or a van occupant, or a truck occupant, and so on. So actually this graph is the second part of the graph you just saw. And there again we see different trends as the ones we've seen before. For example, for van we see a trend like this we didn't see before. For trucks we see a trend with a decrease in the 1970s and 80s, and then it becomes constant and decreases again. So here again many different trends. And to give you the answer to the question I asked with the former slide, these trends are mainly caused by trends in distance traveled with the different travel modes, in combination with improved road safety over the years. And as you can see from this graph, it is quite an art to visualize the data, because visualizing data is an easy way for people to look at the data and understand what was going on, much easier than presenting a table with digits and digits and more digits. Here's an interesting graph showing all variables available for the set of all Dutch road deaths, including those not reported in the police database. So what you're looking at here is the number of people killed as males in the top two panels and females in the bottom two panels in 2006 and 2015, just 2 years to show you things have changed over the years. And from left to right we see different age groups, 0 to 14, 15 to 19, 20 to 30, and so on, in each of the four graphs. And from bottom to top again you see the different travel modes. So here we have pedestrian, bicycle, mobile scooter, disabled vehicle, moped, motorcycle, passenger car, truck, and other. And here we see that the majority of people killed 10 years ago was between 20 and 30 years of age in a passenger car. These numbers have decreased enormously until now. They're well, less than half of them. But the number of people killed as a cyclist has not decreased at all, and has even increased for elderly. So here we see 40 people killed as a cyclist in the age of 80 plus, whereas there are 27 killed in the same age group 10 years ago. And the final thing I want to mention is that we see many more people killed as males than as females, except for cyclists. We have many people killed as many female people killed as a cyclist. So this graphs could help you answer the questions like, what travel modes are most important for Dutch road safety policies? What age groups should we focus on? What about the development in the last 10 years? And do you have any idea why power two-wheelers are not a striking problem, according to this graph, although the risk, as we have seen before, are quite high? I leave the answers to you. The next slides are illustrations from Cameroon road crash data. The Cameroon signalement, which is French for indications, a database, is a small subset of all crashes in Cameroon. If we may believe the World Health Organization, the annual 800 deaths recorded in this database comprise just about 15% of all road deaths annually in Cameroon these days. Then there are PV data in a PV database. That is even smaller, but it shows more data that, however, are often, but not always, left blank or unknown. So it's not always useful to have a database with a lot of variables unless they are all filled in. Nevertheless, for policy making, it is much more valuable than the World Health Organization data, because they only give a number, but they give no information as to what is going on in those crashes. There's no way to know without further analysis of the data what is going on. So we are going to do some analyses. So for example, to the right we have a small graph showing the total numbers of crashes available in those data. We have about 2,500 annually, of which a small sample are road deaths, and it's the road deaths that are probably most accurate, so that's what we are going to focus on in the next slides. In this graph we see the number of crashes with the number of as a function of the number of deaths in each crash, or the number of injured in each crash. Death are in the top panels and injured are in the bottom panels. Here again there are a number of interesting things about these graphs, and you can take your time and think about it. Just a further explanation, to the left we see the number of crashes with people killed. So over here the number of crashes with people killed. Here are the number of crashes with 1 people killed, 2 persons killed, 3 persons killed, 4 persons killed, and so on. Here at the lower panel we see the number of crashes with 1, 2, 3, 4 people injured. And to the right we see the number of people crashed and killed in those crashes. So here we see the number of people killed in a crash with 1 person killed. Here we see the number of people killed in crashes with 2 people killed. It's rather complex, but you see there's a difference between the right graphs and the left graphs. These numbers go down much less fast than the numbers in the left, and actually we see that those numbers are almost constant. So there are as many people killed in crashes with 10 or 11 or 12 or 13 people killed, and this is surprising, and you will get a minute to think about what could be the explanation for this. My explanation, of course it's a guess, I do not know this, but my explanation is that it is because it's highly unlikely that there are as many people killed in crashes with 9 or 10 or 11 or 12 people crashed. It is what is going on here is that when more people are killed in one crash, it is more likely for the police to report this crash. So whereas perhaps there are less and less crashes with 5 or 10 or 15 people killed, it becomes even equally more likely for the police to report those crashes. So this is for me an indication that there may be a strong underreporting of crashes with a few people killed, especially 1 person killed may be grossly underreported. This graph is meant to show that it is sometimes a good idea to switch from linear axis to logarithmic axis if you are studying the data with graphs. Here we see a graph where well, lots of the data are in a big cluster where you do not know what's going on here, and it's a pity because it's a very informative graph in principle, because we have here on a horizontal scale the gross national income per capita, per head of the population, and on the vertical scale we have mortality, which is road deaths per million people in the country. And here we have dots for every country in South Africa for which there are data. The data are from the World Health Organization, and we have put labels for every dot, and the size of the circle denotes the population size. So a big circle like here we have Nigeria or Egypt or South Africa. These are countries with a lot of people. these are large circles, whereas Mauritius or Gabon are countries with a few people, or the Seychelles. But over here we can't see anything because all those data are stuck together, close together. And if you want to see what's going on here, we can use a small but beautiful trick, and that is we could use a logarithmic scale for the horizontal axis, and that's what I'm going to show you in the next slide. So here we have a logarithmic scale on the horizontal axis. We have 200, 400, 800, 1600, 3200, 6400 and 12,800. So every step is a factor of 2 increase. And now we can nicely see what's going on in those low gross national income regions. And all those countries have become visible and distinguishable. So this is nice. I want to make a note about this graph because we sometimes see that people use graphs relating mortality to gross national income and suggesting that there is a relation between the two. Well, of course there is a correlation, but we should surely not assume causality. There's no reason for causality, although if all motorcycle riders in low and middle income countries could afford a car, a passenger car, it would be a lot safer all over the world. And so there are correlations between the two. But we certainly can improve safety with little financial means, although not with little effort, in countries with low incomes. And to do that, we need people to change the system. We now come to the exercise of this part of the lesson. I would like you to look at this list of ingredients for a thorough data analysis, and I would like you to think about which of those are more important. And perhaps you could make your own suggestion of the best order. Which of those is most important and which is least important? You can pause and make your own list. The answer to this question is not trivial. I would say, well, it may be a different situation in different countries. But I would say that although time series analyses, expertise and statistical packages are in the end important to understand the sophisticated issues of road safety, when you have to make a start in your country, you would mostly need the right people, skilled data analysts who can do the best they can with the data that are available. And if you can have good data, well, that's certainly for the better. But skilled data analysts are the first thing to focus on. And focusing those data, visualizing those data in graphs in some way or another, in Excel or in another way, is more important than doing statistical analyses, because they are more difficult to understand for the policymakers you will have to send your advice to.
The next part of Lesson 2 will focus on what can go wrong in data collection. The quality of the data has to do with the amount of information that is available and the skills of the reporting officer. Some information may be hard to identify, such as the speed of the vehicle before the crash or whether a mobile phone was used. And so the officer would usually not fill in these sections, leave them blank, or write down unknown. If the officer isn't trained, then they would get lost when they look through the report of many questions. For example, if you present them with a list of 30 vehicle types, many of the officers will not go through the 30 vehicle types in order to select the correct one. And what they would usually do is say it was the other vehicle type, or just leave it blank. Here we see some examples of mistakes made when reporting a crash. In the Netherlands, mopeds have to comply with a lower speed limit in urban areas. However, when there is a crash with a moped, the officers usually record the speed limit of vehicles on the road. There is usually a confusion between being transferred to the hospital and being hospitalized for treatment. Also, police officers do not always record the exact hour and minute when the crash happens. And so you can see here in the figure with the logarithmic scale the number of times that we have the accurate time of the crash. In Cameroon, police reported crashes were supposed to contain all kinds of variables that were almost never filled in. In Portugal, we have seen 98% of injured pedestrians had a crash in urban areas, while 80% of killed is reported in urban areas. In Cambodia, single vehicle crashes were not considered road crashes to be reported. You may decide to narrow down your road crash definitions so as not to include crashes that are not reported, but that is not going to save the lives of the victims of those crashes. Time series analysis are often carried out to estimate the future number of road deaths in a country. However, accurate time series analysis are very difficult to carry out unless you believe the report rate is accurate. When report rates vary, anything you conclude from time series analysis may be due to report rate variation. That is why World Health Organization data are, in my view, not suitable yet for time series analysis. Another scenario is when corruption is an issue and passenger cars are for rich people only. Crashes caused by passenger cars may be underreported. I mentioned this because in some countries, police officers may be poorly paid and they're practically forced to accept extras at a crash or a violation in order to look the other way. This may be a drawback in policymaking and data collection. There are also examples of countries that did not report or treat victims that could not prove they were injured, possibly because they were brought in unconscious. When police is coping with terrorism, floods, and political tension, they might not have time for road crash reports, and such situations could be visible in report rates varying between months or provinces. When little is known about the causes of crashes and data is insufficiently stratified, an increase or decrease in the number of road deaths may go unexplained. For example, when there is an increase in motorcycle sales or temporarily high gasoline prices. So when you don't know what is going on, it's hard to forecast the future number of road deaths. Other problems you may encounter include countries where only police officers can access road crash data. This is very ineffective when road crash policymaking depends on analysis by the police. I would suggest to incorporate a highly skilled road crash analysis department at the police institute. If there is no road safety institute that can perform analysis and prepare road safety policies, you may take the necessary steps to establish such an institute. In that case, make sure you can hire highly educated staff on a long-term basis. The focus on quality is more important than focus on real-time data. Policymaking usually takes time, many years, and also implementing measures would take a lot of time. So it's better to invest in good data instead of fast and recent data with poor quality. In this exercise, think about why the time of crash is so inaccurately reported. How important is it to know the time of the crash, and what would be the desired accuracy?
The last part of this lesson will focus on what can be done with different data sources and why it is important to have more than one source. With two independent sources, we can check the report rate of each source using capture-recapture methods. To do that, we need to know how many records are in each source and how many are in both. If you just have one source, you can never know for sure that the source is relatively complete or not complete at all. So it's really important to have some way of checking the data in your source with another source. In Europe, we recently found out that there are only 3 or 4 countries who have invested to check their report rate. Some have then adjusted their methods, as in the Netherlands and the United Kingdom and in Sweden. Other countries did do the check, but were not capable or able to change the way they do the reporting, but they do know something about their report rate. Most other countries just rely on the bureaucratic rules. So they say, well, police are obliged to go to each crash site and then check at hospitals if people died. They should do so. Hospitals are obliged to report death to the police. And because this is in the law, they assume that police road crash report rates are 100%. But of course they aren't. They can only be 100% if people and organizations are perfect, and they never are. So it's always a good idea to check the report rates. If you want to read about it, you can find the ETSC pin flash 35 on the website of the European Transport Safety Council. The Dutch Organization for Statistics, which is called Statistics Netherlands, carries out the official determination of the number of road deaths in the Netherlands. And they use 3 sources. And this is actually carried out manually, so they read all the files, they check the names, etc. And what they do is they look at the police reported deaths, they look at the court files, and they look at death certificates of all coroners in the country that report an unnatural death. The results show that all sources are not 100% complete. On the right of this slide, we have shown the results of these checks in 2005. In 2005, we had 817 deaths, and there were 642 of those that were covered by all 3 sources of data. And as you can see, we have 642 here, and there were 33 covered by police and court files, and 78 were covered by police and death certificate files, and 45 were covered by death certificates and court files, and there were also some that were only reported by court files or police or the death certificate data. So yes, this graph shows that you can never be certain of a single source. There are always data missing, and by looking up other sources as well, you are better off. But you still cannot be certain that there are people killed and missed by all 3 sources. Now, suppose you have 2 sources and you would like to estimate the number of people killed that are not in either of those sources. This can be done, and the method you use is called capture-recapture, with 2 captures, one from, for example, the police and the other from the hospitals. And what you do is, it's called capture-recapture because of the experiment that can be done by a fisherman who catches fish from a pond. Suppose he first catches a number of fish, X, then marks the fish, he rings them or he cuts off a fin or whatever, and then he throws them back and catches another number, say Y fishes. And then from those Y a part of them called XY are marked. And from those three numbers, the number called the first time, the number called the second time, and the number that were caught twice, he can estimate the total number of the fish in the pond. And the calculation is rather straightforward and shown in this sheet. So you can read the formula. And the idea is that if the two captures are independent, you can show them, you can plot them in a graph with a horizontal and a vertical axis. And then assuming that there is a probability to catch fish on the first, which is P1 over here, and fish in this case have a probability P1 to be caught the first time and 1 minus P1 not to be caught, and the second time they have probability P2 to be caught the first time and 1 minus P2 not to be caught the first time. Then the probability to be in this section, so to be caught twice, is P1 times P2. The probability to be caught in this section is P1 times 1 minus P2, and so on. And from those probabilities you can derive a very simple equation that is in the red square, in the red rectangle. From that you can estimate the number of people that were not caught at all. And you can apply these methods to data from road crash reports, and it's been done. And it's a useful thing to do. So as an exercise, let's try to see if we can estimate the number of road deaths in the Netherlands, where the police reported a total of 422 deaths. The hospital reported a total of 287 deaths, where there is an overlap of 173. Remember to use this formula, and remember that the overlap is part of the 287 and part of the 422. I suggest you pause for a few seconds and see if you can reproduce the number of people killed, but in neither of both reports. So here we have the calculation of the result, and first we calculate the number of people killed according to the police, but not also according to the hospitals. This is 422 minus 173 is 249. We do the same for the hospital records. Those 114 are only in the hospital records. And we have the overlap 278, and applying the calculation results in 99 people killed but not reported in either of the reports, in either of the databases. And then the total number is the sum of all, and it's 700, which leads to a 60% report rate for the police and slightly more than 40% report rate of the hospitals. Now, I'd like you to think about the following. Why are those hospital report rates less than the report rates of the police? Can you think of a simple reason? The answer is you must remember that people who killed on the spot will never go to a hospital. So whatever the report rates, one would expect the hospital report rates to be less, just because many people never reach a hospital. So, well, we'll end by assigning you the homework exercise for today. It is going a step further than just a continuation of the lines of thinking in this course. For this assignment, you need to do some research at home or at work, whatever. The question is to explore the internet, make telephone calls, arrange interviews with relevant people if necessary, and see if you can find out how to get access to the police crash database in your country. and perhaps you already have access, and then it's an easy exercise. But then you could ask yourself, if someone working at a municipality in your country or working for an organization in the country who is interested in road crash data, how could someone else from you get access to those data? Are those data easily accessible, or is it very difficult, or are those data exclusively available for the police? Because in an ideal situation, police data should be accessible to all relevant policymakers, either through a low threshold research institute or directly. It is a really bad practice when a country has arranged that police crash data are accessible by police officers only. And if that is the case in your country, you need to find a way to start moving toward a change in that situation.